Humans make more than 6 million metric tons of potato chips each year, and most of them come in bags like this. They're typically made of multiple microlayers of plastics and aluminum, each serving a different purpose, and they're engineered to keep snacks fresh and crisp for 6 months or longer. But this sophisticated design, used in everything from yogurt pouches to juice boxes, has created a major environmental problem since the material almost always ends up in landfills.
It's considered quote-unquote impossible to recycle.
Anish Malpani quit his finance job and dedicated his life to solving this problem. Since 2021, his startup has recycled 300,000 chip bags into sunglasses. But why are these packages so difficult to recycle? And are big manufacturers doing anything to fix the problem? In the early 1900s, chips were often sold from open barrels and glass jars and packed into paper bags, where they stayed fresh for only a day. Over the following decades, companies packaged them in things like waxed or glassine paper or tin cans to boost shelf life. In the 1950s, manufacturers began selling their chips in cellophane and paper bags lined with aluminum foil, extending their shelf life by several weeks. They offered better resistance to moisture and light, but they didn't have an airtight seal. In the 1970s, a revolutionary process called co-extrusion allowed manufacturers to layer several types of plastic into a single film, creating the first generation of multi-layered packaging. By the 1980s, many foods were being sold in 3 layers of packaging. Today, some of these multi-layer packages, or MLPs, can have as many as 11 layers. The middle of a modern chip bag is usually made from plastic resistant to oil, grease, and moisture. But this doesn't fully block oxygen or light, so it's often coated with aluminum to form the innermost layer. The bag's outer layers must be strong, flexible, and printable, so they're made with 2 plastics. The undercoat has the graphics, the outermost layer protects them. Before a bag is sealed, it's filled with nitrogen gas to create a low-oxygen, low-moisture atmosphere. Together, this design helps chips stay fresh and crisp for 6 months. And this deceptively simple-looking design is everywhere. In 2023, the world produced enough MLPs to fill about 4 million garbage trucks. And most recycling facilities don't have the technology to separate or process these packages. So they are usually sent to landfills or incinerators.
MLP is the black sheep of the plastic family. Nobody wants this material.
That includes most waste pickers, who normally can't sell this ubiquitous kind of trash.
So finding a solution for this where they can be compensated fairly is of utmost importance to the waste pickers.
Lubna Ananthakrishnan works for Swatch, a cooperative of waste collectors that only started gathering MLPs after a giant manufacturer started paying for it. Now, Anish buys 100 kilograms of thin plastic wrapping from Swatch every month. Without's headquarters is just one of a handful of places in the world that can recycle MLPs.
Because we were approaching this from a problem-first perspective, we chose the things that nobody wants to work on. In the beginning, many people thought we were idiots, like, what are you doing? This doesn't make any sense.
Anish and his team spent a lot of time buying and modifying common manufacturing machines like shredders and extruders to recycle these packages.
It's not like all of them are designed by us or all of them are off the shelf. It's a combination. It's like a jigsaw puzzle, right? You're kind of finding the space and making it.
First up is a modified shredder. It's equipped with a special vacuum that pulls the lightweight films through so it doesn't clog.
MLP or chips packets are very light, so it's very hard to sometimes shred them. You need extra force to suck the material so that it actually gets shredded properly. In the first shredder, we could do only about 1 kilo an hour maybe. Now we do 10 kilos an hour.
Workers wash the flakes to remove any glue or dirt. Then they skim them and transfer them to drying racks. A technician weighs the dried flakes before loading them into the company's real innovation, a custom-built 100-liter reactor that reaches about 250 degrees and actually separates the layers. It took 2 years to figure out the right process. Anish doesn't have a science background, so when he started Without, he placed an ad online looking for someone to help him build machines that recycle the unrecyclable.
I was like, hey, I'm looking for a scientist to help me tackle this.
That's how we found Dr. Jitendra Samdani. Jitendra's main challenge was to discover how to separate the mix of commonly used plastics that make MLPs.
That's why people don't go towards the MLP recycling. It's not a simple kind of waste.
He tried over 1,000 experiments until he figured out the right reaction that would isolate 3 of the most common types of plastics: polypropylene, polyethylene, and PET.
That's the moment we say the wow moment for us.
Jitendra built the reactor to standardize and scale his new process. It uses water with a high pH to cause a reaction that partially separates the layers. The reaction dissolves the aluminum and breaks the PET plastic into its basic molecular structure.
And then what we get is a bunch of building blocks.
Anish's current R&D lab can separate about 8 kilograms of material a day, but he wants to get closer to 100 kilograms before he opens a larger plant.
And we're still working on improving the rate of the reaction because we need to make sure that we can do it in the most efficient way possible.
The reaction leaves behind a mix of plastics, some of which can't be used to make Without sunglasses. Eventually, Anish wants to make bricks with them, but for now they're just stored on site. To get the needed PET plastic, workers wash the mix with sulfuric acid. Then, they load the flakes into a barrel full of water and connect 2 hoses to something called a hydrocyclone. It's typically found in agriculture, and it uses centrifugal force to separate sand and mud from water. Here, that force separates the lighter plastics, like polypropylene and polyethylene, from the heavier plastics, like PVC and nylon. The material is continuously run through both the barrel and hydrocyclone for 45 minutes, until the only thing left are the lighter plastics, which get skimmed off the top. The plastics are dried overnight at 60 degrees Celsius. In the morning, workers remove the flakes and run them through a machine that compacts them into a more solid form. Workers then load it into a mixing machine and sprinkle some of the naturally green materials with a fine black carbon-based powder.
Our material is not transparent. It's either green, gray, or black.
A technician pours the flakes into a customized twin-screw extruder that mixes, melts, and pushes out the plastic as a filament.
We don't add any virgin plastic, but we do add additives and compatibilizers to give it the energy and the life that it requires.
These additives include widely used chemicals which improve the plastic's overall quality and durability. The filament leaves the extruder at 200 degrees Celsius, and it's cooled rapidly with water tanks. Another machine cuts the filament into pellets. Recycled plastic often starts in pellet form before it's shaped into a final product, and it took over 2 years for Anish to figure out what his would be.
So we brainstormed over 400 different products. We shortlisted 70. Then in the 70, we looked at 27 different parameters based on like team excitement, complexity, average Amazon searches and margins and all of that. And then sunglasses scored very highly on that.
The pellets are melted and injected into molds for frames and hinges. Anish estimates that a single pair of glasses takes about 5 packets of chips. A robotic arm stamps the hinges with a logo and a QR code so buyers know where and when their frames were made. Workers assemble each pair by hand-cutting plastic lenses imported from China and screwing frames together.
So we can make between 500 to 1,000 sunglasses a month.
All told, the company has recycled 1,500 kilograms of MLPs.
That's like close to 300,000 packets of chips. It sounds big, but it's not a lot. We're like a drop in the ocean.
For now, Without only sells them online in India for $10 a piece. But Anish hopes to expand the product to the US, Europe, Australia, and New Zealand. Anisha's process is complicated, but it only took a small team to figure it out, so why isn't everyone doing this? Most plastic recyclers are designed to handle one kind, such as PET or PVC or HDPE. Processing mixed plastics would require retrofitting old equipment or developing new machines that could detect and separate them. Because separation almost never happens, there's no market for the mixed materials Anish is working with. Recycling them profitably is practically impossible. We looked around, and outside about a half a dozen pilot projects, MLPs are almost never recycled at a commercial scale. One of those projects is at the University of Wisconsin-Madison, where Professor George Huber and his team spent 6 years developing a way to process MLPs using solvent washes. They call it STRAP, short for Solvent Targeted Recovery and Precipitation.
So this is a film we made. We pulled out the polyethylene from this, and we went back, we made the powder, we made the pellets, and then we went to remake the film.
The STRAP team is building a pilot plant that can process about 25 kilograms of MLPs an hour. But they'll need to recycle at least 20 times that to be profitable.
And then you go larger than that, 1,000 kilograms per hour, you're looking really good.
That kind of scale takes huge resources. Indeed, a lot of MLP recycling is only possible with corporate subsidies. Remember how Swatch started collecting MLPs? It's because a giant food supplier that makes them, called ITC, sponsors the program.
If you really look at the costs of buying it from a waste picker, aggregating it, sorting it, and then getting it to a recycler, the value generated from MLP today is not really enough for this to be viable.
Other companies have also struggled to tackle MLP waste, partly because the packaging is so popular with consumers. In 2010, SunChips released a compostable chip bag made from PLA, a biodegradable plastic sourced from cornstarch. While it was actually compostable in a compost pile larger than 21 cubic feet, customers complained about how loud it was.
The only problem? It sounds like a hailstorm.
SunChips sales declined, and the company stopped making the bags 18 months after their release. In 2022, Frito-Lay reintroduced a compostable bag for its brand Off the Eaten Path. It was quieter, but could only be broken down using an industrial composter, not the one in your backyard. That same year, one of the world's biggest MLP manufacturers, the Swiss company Tetra Pak, started working with schools in Thailand to recycle milk cartons into various building materials. This school goes through about 5,000 containers a month, and nearly all of them get recycled.
และทุกๆเช้าคุณครูก็จะให้ตัวแทนห้องเรียนมาแจกนมพอดื่มหมดแล้วนะคะก็พับกล่องนมตามวิธีที่คุณณัฐวัฒน์ได้สอนไว้ค่ะ
สอนนักเรียนนะครับให้รู้จักของการคัดแยกขยะแล้วเนี่ยก็ยังจะต้องเหมือนกับทำประโยชน์ให้กับสังคมด้วย
The recycling program is active in over 400 Bangkok schools, as well as more than 150 drop-off points across the capital. The cartons end up here at Eco-Friendly Thai, a recycling company that specializes in beverage containers and used paper. The Ratchaburi plant processes about 12 million cartons a month. First, they have to be broken down to make it easier to separate the cardboard from the plastic and aluminum. The walls of the cartons made by Tetra Pak have 6 layers. All of them can be recycled on their own, but many recycling facilities don't have machines that can process them all at once. About 70% of the carton is paper, which provides structure. Polyethylene plastic makes up 20% and helps seal the packaging. The last 5% is aluminum. A thin foil helps keep the contents fresh and extends the product's shelf life. And a special heating process sterilizes both the product and the package, making some items shelf-stable for up to a year. The hydropulper breaks up the layers into tiny pieces. Then, the boxes go through 3 filters to separate and remove the paper. Each filter is finer than the last. Any wastewater gets pumped back into the pulper.
น้ำที่ใช้ในกระบวนการรีไซเคิลสามารถกลับมาใช้ซ้ำได้
The remaining plastic and aluminum end up here at the dump screen. Those will get turned into building materials like bricks and roofing sheets. The pulp is trucked to another plant and will be turned into toilet paper and cardboard. But this is a fraction of Tetra Pak's overall output. The company says it reclaimed 390 million containers in 2023, just 7% of the cartons sold in Thailand alone. While new technologies promise to make recycling more efficient, it's unlikely we'll be able to recycle our way out of this problem. The global market for multi-layer packaging is growing, and it's overtaking other types of food packaging. By 2023, the market is projected to be worth more than $250 billion. The EU wants all food wrapping to be recyclable or reusable by 2030, but that will be very, very hard if facilities can't identify, sort, and recycle multi-layer packaging.
We need the people making MLP, the producers making MLP, to be genuinely responsible for the material they're putting in, and realistically for the solutions for MLP to be able to work at the scale of the problem.
Some brands are returning to monolayer plastic films, like these ones, made by a company called Topan. But they aren't perfect.
We don't really recycle films very well at all right now. And so no one is really buying these monolayer materials.
For now, Anish plans to continue refining his process, trying to make it work on an industrial scale.
And I'm not trying to look for a quick hack. I'm looking for real systemic, permanent change. And that takes time. And that requires commitment. And that's when the real work, the real impact starts coming in.